mixing sulfuric acid, powdered sugar, and I'll be getting a product that is made up of H2O, carbon, and you might notice in the chemical equation that I had sulfur, but the sulfur is gone. That's because it is emitted into the atmosphere. To do this experiment, you first have to have the proper lab safety gear, which includes a lab coat, eyewear, and some gloves.
Atomic structure. Atoms are the smallest possible units into which matter can be divided while still maintaining its properties. There are 3 subatomic particles located inside the atom: the electron, protons, and neutrons. The electrons are negative, which are located on the outside of the atom, and the protons are positive, and the neutrons are neutral. Those 2 are located in the nucleus.
For Unit 3, we discussed the periodic table, and we learned how the structure of the periodic table allows us to predict different trends and properties of elements. In our recent experiment, we used carbon, hydrogen, oxygen, and sulfur. These are all nonmetals in the main group elements. On this periodic table, we see that oxygen is closest to fluorine, which means it's the most reactive and has the most electronegativity. All carbon, hydrogen, oxygen, and sulfur are all nonmetals, which means they're dull, brittle, non-conductive. They have low melting points, low boiling points, and a low density. However, metals are good conductors of electricity, malleable, lustrous, have high melting points, have boiling points, and high densities.
Talked about bonding. The first type of forces in bonding are intramolecular forces. The 3 types of intramolecular forces are covalent bonding, which is between 2 nonmetals that are sharing their electrons. Hydrogen here is sharing its electrons with oxygen. And then next is ionic, where a metal and a nonmetal are transferring their electrons. Sodium is transferring its 1 electron to chlorine. And then the last kind is metallic. And a metallic is when two metals bond and their electrons become delocalized in a sort of electron sea. Now there are also intramolecular forces, which are these are what keep atoms together rather than keeping molecules together rather than keeping atoms together like up here. The first kind is London dispersion. This is just a simple low-level bond that all molecules have. The second kind is dipole-dipole, which only polar molecules have. And the final kind is hydrogen bonding, which only hydrogen, fluorine, oxygen, and nitrogen can have. This is the strongest bond. Now, atoms bond so they can go to a lower energy level. They want to have minimal energy and they want to have filled octets.
Okay, so for this experiment, I'm making 150 milliliters of powdered sugar and 150 milliliters of sulfuric acid. Here's the equation that I'll be mixing, and as I said before, the sulfur is emitted into the atmosphere, so the law of conservation is still intact. Baking soda is a strong base. If anything gets on me, it will neutralize it. Hopefully that will not happen. And I have a stir to stir it all up.
Oh, Lord.
As you can see, the chemical reaction has occurred. The 150 milliliters, that's awesome. The 150 milliliters of powdered sugar and the sulfuric acid have mixed together to produce the product, which is H2O and carbon. And you pour a little bit of the strong base to neutralize this. Alright, that's good.
Equation for the experiment that we did. Our acid is sulfuric acid, which is represented as H2SO4. And our water is going to be acting as the base, which is represented as H2O. This chemical equation is already balanced. Since our equation is already balanced, we're going to use a hypothetical situation. We're going to use the chemical equation for water. As you can see here, it's H2 plus O2 yields H2O. And to figure this out, you have to put H and then O and then say how many is in on each side. And so since this is not balanced, you have to add a 2 here and then add a 2 here to show that it's equal now. But now this one is at 4, so you have to add a 2 here. After you do that, it is balanced.
Talking about kinetic molecular forces or kinetic molecular theory. Now there are 5 assumptions six assumptions stated in kinetic molecular theory about how gas molecules act. The first is that they are composed of a large number of particles that move randomly. Second, that they move in a straight line until they collide with the walls of their container or other molecules. Third, that gases are mostly empty space. Fourth, that there are no attractive forces between the particles. Fifth, that there is no energy lost whenever particles collide together. And sixth, that the average kinetic energy is only dependent on the temperature. Now we use this equation, Ke or kinetic energy equals 1/2 mv squared to find the energy. M is mass and V is volume. Here are the 3 facts stated by the theory. That if you increase the number of atoms, you increase the number of reaction rates. If you increase the kinetic energy, then you increase the pressure on the whole system. And that if you add a catalyst, you decrease the amount of energy needed, so the rate of reactions increases.
Heat and phase changes. So in this lesson, we're going to talk about how changes in heat and pressure can affect the changes in the state. And as you know, temperature can make the difference between a solid and a liquid. Pressure pushes these molecules closer together, which can be the difference between a gas to a liquid. So, how does energy flow from one object to another? Well, in the picture, you can see that heat transfer goes from a warmer object to a cooler object. And in the earlier experiment, heat was released when the product was released into the atmosphere. The smoke was when the energy was being transferred. In the bottom, this is 3 states, liquid, solid, and gas. And as you can see, the phase changes in this picture. There is sublimation, melting to freezing, vaporization, and condensing.
Discussed how different equilibriums can be disturbed by different stressors such as temperature, pressure, and concentration. For our experiment, however, it did not reach equilibrium because the sulfuric acid was released into the atmosphere as a gas. And since it was released, it can't be taken back and make a reversible reaction. Sulfuric acid is released into the atmosphere. To reach equilibrium, you'd have to shift the reactants to the right to favor the products. To represent equilibrium, we use the equilibrium constant. As shown here, you use the products over the reactants. Collision theory, both temperature and the amount of collisions are directly related. During our experiment, we found that the products, powdered sugar and sulfuric acid, raised the collision rate, which caused more heat to be given off.
Why, hello there. Thank you for watching this video. I hope you found it as informative as I did. Thank you to my group members, Lauren, Misty, Bethany, and Katie. Thank you, Miss Peele, for being a good chemistry teacher. This is the product that we ended up with the sulfuric acid and sugar experiment. This is the chemical formula and equation. Always wear your safety gear, kids. Well, I'm still talking about this. Goodbye.
And that's all, folks.